right. Hello, everyone. Welcome to CS444 compiler construction. And I'm just going to wait about 20 seconds because the way that Learn works is somehow it starts letting people into the room gradually, and so there's everyone's sort of appearing gradually. So just give me a few seconds for everybody to get in here. Okay. All right, so that might be everybody. All right. Okay, so hello. So my name is Ondřej Lhoták, and this is CS444 compiler construction. So my name, some people find it hard to pronounce my first name, so feel free to call me Ondřej, or if you prefer, feel free to call me Professor Lhoták. Yeah, so the course is online, obviously, and so it's not going to be quite the way that I would like to teach the course, but we were online last year, last winter term, at the end of the term, and it seemed to go pretty well. So I'm going to just follow the way that I taught the course last term. Okay, so the course is on compiler construction. So, you know, I wanted to start with introducing a compiler. Now, you probably have all used a compiler before, but, you know, let me draw one anyway. So here's my compiler. And so a compiler is a program that translates other programs from one language to another, right? So the input to my compiler is a source program in some source language. And then my compiler is itself a program. And then the output of that program, the output of the compiler, is a target program, a program in a different language. All right. You know, one of the things we try to do when we're writing the compiler is to preserve the meaning of the source program. So we want the target program to have the same meaning and the same behavior as the source program. And, you know, I mean, you've used compilers before. I can give you some examples of source languages and target languages. You know, so sort of the standard example is your source language could be C, and your target language might be assembly language for some specific kind of processor. And then your compiler is the way that you enable your C program to run on different kinds of processors with different assembly languages, right? You could have one C program, compile it with different compilers to run on different processors. Okay, but I mean the source languages and the target languages can be different. So another common example is Java as the source language. And typically when we compile Java, we would compile it to a kind of virtual assembly language called Java bytecode. Okay, and then typically for Java, we would then have a second compiler that it's a just-in-time compiler that runs while your program is running, but it just compiles your program, you know, right before that part of your program starts running, but it is still a compiler, and so there the input would be Java bytecode, or the source language, and the target language would be assembly language or machine language to actually run. Okay, so I mean, the source language, the target language can be various languages. But so one reason why I mentioned Java here is that in this course, the big project is going to be to write a compiler for Java. And we're going to do something a little bit unusual for Java in that we're going to compile Java source code kind of, all the way down to assembly language, x86 assembly language specifically. And sort of the reason, I mean, that's not normally how you would compile Java. You would go in 2 steps. You would use 2 separate compilers. But, for the course, we want to build a compiler for a real language, so Java. But, I mean, I want you to experience writing the whole compiler, including the backend that produces assembly language. And so that's why we go from Java not to bytecode, but all the way down to assembly language, so that you can practice or experience writing the backend of the compiler. Okay. All right. Now, so okay. So there's the big picture overview of what a compiler is, and I'm sure this is review, and you've seen compilers already. Let me just pause a little bit now that we have hopefully everybody here. So I mean, in the lectures, I do have a big class, but I would like them to be somewhat interactive. So I would like to give you a chance to ask questions. So if you have any questions, you can either write them in the chat, and then I will answer them. Or if you would prefer to ask your question verbally, say question in the chat, and then I'll call on you, and you can turn on your microphone and ask the question. And I'd like to try to keep the lectures interactive throughout the term, just because for many of us this is like the only interaction we have, and so I want to maximize that, make the most of that. All right, and so please ask questions. Please do the lectures for interaction. They are recorded, so if you miss them, you can watch them later, but then you don't have the interaction there. So please try to attend them live, and please ask questions. And I see we have Josh has a question. Josh, go ahead.
Yeah. Hey, I'm just kind of curious, when you're compiling a language like Java down straight to assembly, where the runtime has like garbage collection and all sorts of sort of stuff going on in the background, how does that work? If you're compiling it directly to assembly that runs right on the metal, what happens to the garbage collection and stuff?
So, all right. So I mean, with Java, you need a garbage collector. So so if you so you do need to provide the garbage collector to run together with the program. For the purpose of the course, well, let me do the general thing first, and then for the course. So in general, if you wanted to run, if you wanted to compile a language that requires a garbage collector, you would link the garbage collector together with the generated code, and the garbage collector, there's kind of a part where the compiler has to be aware that a garbage collector is going to be used, and it has to generate some code that would tell the garbage collector how to do the garbage collection, what the object layouts are in memory, and where the pointers are. So the compiler would need to generate that extra information, but then the garbage collector itself is just a program that can, or just a library that can run together with the compiled program, and you can compile that separately possibly with another compiler, depending on what language that garbage collector is written in. Oh, right. And so for the course specifically, we're going to kind of steer around that issue, just because writing garbage collectors could itself be an entire course. And so we're going to use a really trivial garbage collector that doesn't actually collect anything. So some of you, if you took CS444, when I teach that, I have you first write that kind of a memory allocator that only ever allocates memory and never frees it. And so that just lets us avoid having to worry about garbage collection. There is a lot of work to do just in the course, just on the compiler, and we're not going to have a lot of time to add a garbage collector. All right, is it Yashin?
Yeah, that's correct pronunciation.
Okay.
Thank you. Dr. Andre, I just have a question saying like the current video is kind of blurry for me, and for future lectures, will you use slides or are you just going to
sorry, the whiteboard is blurry?
It's, yeah, very blurry. But I can still see right now because I write pretty large fonts, and but it's blurry for me, yeah.
Okay. Video quality is pixelated, poor resolution. Okay, let me just see. So I've been using Learn for lectures in 241E. I see. So for some reason, I was on Wi-Fi and not wired. Is it still poor quality now? Did nothing change?
I think it's a little better. I think once you stop moving or writing anything, it's better. And once you start to moving, and it's kind of turning blurry a bit and changing back. So.
Okay. All right. Well. Okay. So I'm gonna do this for now for the lecture, and then maybe later in the lecture. Okay. Some people are saying it's improved, so we'll see. I'm also going to watch the recording afterwards to see what happened. Anyway, okay, so let's try this for today, and then I'll decide what to do for the future. Okay. All right. Anyone else? Okay. So I just have to not move. All right. Okay. All right. So it's going to be hard to not move. Okay. So let me talk about the compiler a little bit more. And so far it's just a box that does this translation. But we can take the compiler and split it up into multiple parts. And usually the first split is into a front end and a back end. So front end, back end. Okay. And the idea is that the front end takes the source program and tries to understand what the source program means. Actually, one thing I could try, if I move things back, that makes things smaller, but maybe it makes it there's less movement there. Okay, all right. So the idea is that the front end it tries to understand what the program means, and so we can also call this analysis. So this is where we're trying to understand what the source program means, and then the back end is what generates the target program, the output program, right? And so another word for that is synthesis. Okay, and so I mean we're going to look at both the front end and the back end of the compiler, and then the front end and the back end I can further subdivide them into more parts. So I'm going to divide things into quarters here. And so sort of in the first part of the analysis is where you would do your scanning and your parsing. And so this is where we just try to determine the textual structure of the code that we're compiling. And then there's context-sensitive analysis. All right. And when if you took CS444 or 241E, the context-sensitive analysis was a fairly minor part of the analysis, but for realistic programming languages, this is kind of where most of the work of a compiler is. There's a lot of details to typical languages that all need to be analyzed. So, this tends to be a big chunk. So accordingly, this is going to be a fairly big part of the course. And so for scanning and parsing, we're going to have assignment 1 is going to be about scanning and parsing. For context-sensitive analysis, it's going to be assignments 2 to 4. So, 3 assignments. They are 3 smaller assignments than assignment 1, but it is still a larger part of the compiler than just a single than the single assignment for scanning and parsing. Okay, and then at the very end we do code generation. All right, I can't fit it in here. All right, so code generation is where you output the assembly language code or the target language, and for us that's going to be assignment 5. One interesting but not covered part is optimization. So optimization. Okay, and so this is once the compiler has understood the input program, before it goes to generate the target code for it, it can transform the program in various ways to hopefully end up with better output code in the end. And this is a really interesting topic, but there's already a lot in the course. And so we have a separate course that is all about optimizing compilers. It's a grad course, CS444. And so we're not really going to talk much about optimization in this course. Having said that, I am going to cover, maybe 1 or 2 lectures about some of the basics of optimization, but it's not going to be a main part of this course. Okay, so now we have sort of the big picture overview of a compiler, as well as a big picture overview of the course itself. I want to go through the course website. I know, you should all read the course websites on your own in depth, but there's just various points that I want to touch on about, how the course is going to work. Before I actually show the website, I think the 3 key ways that I'm going to communicate with you are, the website is one of them. These lectures on Learn are the second one. So, I hope you can attend them. And if you can't, they're recorded. And the third one is Piazza. And so, that's where you can ask questions and, have discussion about questions about the course. Please follow those 3 things because that's where you will see information about the course. Okay, so I'm going to share my screen here. All right. And show the course website. And maybe, well, I don't know. How big do I need to make it for it to work on Learn? So hopefully this is big enough. Okay, so we have the lectures. They're recorded. Attend live if you can. So here's my name. This links to my website. My email that's my user ID at uwaterloo.ca. I have an office, but it's been almost a year since I've been there, so don't go looking for me in my office. I'm going to have office hours on Wednesdays after the lecture on Teams. And there's on Teams, there's a channel there. So during that office hour, you can post a message in that channel to say, you know, please call me, and I'll call you in order that you show up in that channel. Okay, so that's how office hours will work. If that time doesn't work for you, that 2:30 to 3:30 on Wednesdays, email me to set up a different time. And so we have 3 TAs, and I'll tell you a little bit more about what the TAs will be doing in a little bit. The course website is here, Piazza is here. I'm gonna assume that you have all used Piazza before. In case you haven't, it's you know, fairly straightforward. You post questions, you see answers. There's some stuff about what the course is about. You know, basically what I've shown on the board. And there's this acknowledgement here. So I just want to say a couple of things about sort of the history of this course. So the course, you know, way back when I took it, which was, so when I was doing my undergrad, I think it was like 20 years ago now, which is kind of scary. But you know, when I took the course, we didn't compile Java. Java was really just getting started back then. We compiled Ada, but the course was very open-ended. So essentially, you could you know, make up your own mind about what subset of Ada you wanted to compile. You could you know, compile it any way you wanted. You could write the compiler in any language that you wanted. And so sort of you had a lot of freedom. And that freedom is a big part of the tradition of the course. And so you will still have almost all of that freedom, you know, when you take the course today, 20 years later. And you know, part of that is because writing compilers is something that's like riding a bike. You have to do it by practice. And, you know, you will write your first compiler and you will do some things right and some things just won't work out the way you wanted. And so then when you write your second compiler, you'll do certain things differently and improve some things and, you know, make some other mistakes. And you it's kind of a trial and error kind of thing, just because a compiler has many moving parts. And so, you know, I mean, even highly experienced compiler developers, you know, they still write a compiler and they think, oh, well, there's some things about it that I didn't like, and then they write their next one and they change something. So I think that freedom to do things your way, to try things out, and, you know, possibly have to tweak things and learn from mistakes is a key part of the experience of this course. So I'm kind of keeping that, but you know, back then it was a little bit too open-ended, and you know, you would write your compiler, you would write a little document saying what it did, and then the prof would just read your document and make up a mark out of nowhere. So, I wanted things to be a little bit more objective. And so a number of years ago, when Ada was getting kind of old, Michael Schwarzbach, who was a professor at Aarhus University, designed this course that was all about compiling Java, and he specifically wanted other professors and other universities to use his course materials. He wrote a paper about the course and how it all works, and so I talked to him, and I got some of the Java-related material and plugged that into our very open-ended course. All right, so that's so the course that we have now is kind of a hybrid between these two courses. So there is still a lot of flexibility. So you can still write your compiler any way you want using any implementation language. But the language that we are compiling, which is Java, or a specific version of Java called Juice, that part is well defined. So all of the compilers that you are going to write are all going to compile the same language, and that means that I can give you marmoset tests that will test whether your compiler correctly implements that specific language. Okay, and so that's the benefit. So the marks can be based more on whether your compiler passes a test suite rather than just kind of looking at what you've done and assigning a mark. Okay, so the source language and the target language are defined. I tell you this is what they are. The language in which you implement your compiler, that's still up to you. And the techniques that you use to implement your compiler, those are up to you as well. In the lectures, I will be giving you some techniques that you can use. But if you don't like them, feel free to experiment with other things. Okay, so let me know if there are questions. And if I don't see any, I'll just keep going. All right, so there's some links to resources on the website. The one that I want to highlight here is the Java language specification. So this is going to be, this combined with Juice is going to be the specification of this source language that we are compiling. And so the Java spec, it comes as a book. It was published as a book, and you can buy it in paper form. It was also available, freely available online. It is now quite old because this is for Java version 1.3, so a version of Java before Java got generics. But it is available online on archive.org. That is a website that keeps around copies of old websites. So there's a link to it here that you can get it online. If you want a paper copy, they're actually pretty cheap because it is sort of an outdated book if you're trying to get a spec for the latest and greatest version of Java, but it's just the right Java for us. So I'm specific about the second edition. So each edition covers a different version of Java, and we want the second edition. If you come across the first edition, there's a useful aspect of the first edition. It has a LALR1 grammar, and so we'll talk about what that means in later lectures. But it has this grammar, in one of the chapters that is going to be useful for the parsing phase of your compiler. And then, after the first edition, they dropped that grammar out of the spec, and you kind of have to design that grammar yourself. But that first edition has that grammar. The other, okay, and then I see a question, is there any recommended implementation language? So I will get to that. Let me just say one more thing about Juice. So, okay, so we have this spec. So this book is a specification of Java 1.3. So this is the language that we're implementing. But then there's this website or this web page, the Juice languages, and basically, you know, it's this one gigantic table, and so in the table it has all sorts of Java features. Okay, and each feature you can click on it, and you get a little example program where the use of that feature in the program is highlighted in blue. Okay, so you know, if you want to understand what each of these features are, you know, click on them to get the example. And then there's a number of languages here, starting from Juice 0 up to Java 1.3. So Java 1.3 is what that specification specifies. And then there are various versions or subsets of Java that are the different juices. And the one that we care about is this Juice 1W. So Juice 1, I guess Juice 0, 1, and 2 come from this Aarhus course. And the juice that we want to implement is, you know, mostly Juice 1 with some small tweaks. And so that's Juice 1W. The W there is for Waterloo. Okay, so I mean, you can pretty much ignore the other columns, but they're just there for completeness, you know, because this chart originated from that previous course. Okay, so so the idea is if there's an X in the column for Juice 1W, you should implement that feature. If there's no X, then our compiler does not have that feature. And, you know, for the most part, it follows Juice 1. Okay, so, you know, all these advanced features are things that are in Java 1.3, but you don't need to implement for the course. You know, I mean, having said that, and even though in the chart it looks like we're missing a lot of things, we are going to end up with a fairly complete a compiler for a fairly complete subset of Java. These tend to be sort of the more obscure and small features that we're excluding. Okay, so in terms of questions of what is our source language, the two references for that are the Java spec and this chart of the features. And if you have questions about, you know, details of the source language, you can ask them on Piazza. But for the most part, it's, you know, look in the spec to say that tells you how each feature actually works, and look in this chart to tell you which features we have and which features we don't have. Okay, so, and Neil has a question, are there recommended implementation languages? So, you know, this is the part where it's up to you. I would recommend a language that you're quite familiar with. The course project, you know, it's a big project. You are going to write a big chunk of code, and doing that while, you know, learning a new language, you know, might be extra challenging. I know, I mean, I do have students who kind of use this as an opportunity to really learn that language that they, you know, really wanted to learn and never got around to. Just keep in mind that that's an extra challenge. I have, you know, I mean, in terms of past experience, I've had students use all sorts of languages. Typically, you know, I do have many students use kind of the obvious kind of common languages like Java and C++ and whatever the popular languages are. But I also get lots of more weird and really more weird languages. So it's really it's really a mix of what students choose to use. At various times I've tried to see if there's any kind of correlation between the language that you choose and the how well students do. And for the most part, I haven't really found any correlation. Typically I will get some really terrible C++ solutions, some really great C++ solutions, and some, that are kind of in the middle, and, kind of same for the various other languages. It seems to depend, I certainly have the languages I like. If I was doing the project, or I have done the project and I did it in Scala, and I think that was a good choice for me. But I think how you structure your compiler, how you design things, how cleanly you write the code, how thorough your unit testing is, that tends to affect things more than choices of specific languages. The one kind of warning, I guess there's two languages that people have had trouble with, some people have not had trouble with them, but some people have had trouble with them. So the two are Haskell and Rust, and I know they're really popular, or some people really want to try Haskell. Yes, Haskell is such a nice language. Or Rust. Yes, there's lots of cool things about Rust. I think what happens is those languages, I think those two languages in particular, really enforce specific ways of designing your code. In the case of Haskell, it's required to be purely functional. In the case of Rust, it imposes a lot of restrictions on how you set up your data structures. And those are things that you have to take into consideration when you are designing sort of the overall design of your compiler. And I think where students get into trouble with those languages is they start kind of coding in them as if it was C++, and then they realize, oh, well, okay, that kind of approach doesn't work, and then you have to do a big redesign. So for those languages in particular, I would suggest to use them only if you have some experience with them. But of course, I suggest that every year, and lots of students don't listen, and they say, oh, this is my first time using Rust and I'm going to use it anyway. And roughly half the groups deal with that just fine, and half sort of have trouble, and end up having to do a lot of refactoring in the middle of the course. And in many cases, they do that refactoring and then it's all fine, but it is an extra chunk of work there. So I don't know. I like those languages, and I do want you to experiment with things, but I also want to caution you, based on the experiences of past groups. And I'll repeat that some groups have done really well with Haskell and really well with Rust, and once you get it working, it does lead to really nice and clean and robust compilers. So it's a trade-off, but it's a decision that you make. Pick a language that you're comfortable with, and if you pick a language that you want to use because you're going to be using it to write a lot of code. But, on the other hand, if you pick a language and you decide you hate it, well, it's not the end of the world. It's just one course, and your second compiler or your next compiler that you write after this course, you might decide to use a completely different language. All right, and Josh has a question about target language. Will I be able to run the compiled source directly on my machine? Okay, so the target language is x86 assembly language. And specifically the 32-bit version of x86 assembly language. So pretty much any laptop that anybody has nowadays should be able to run that in Linux or so for Marmoset we use Linux for testing. So sort of the standard environment in which your compiler will be tested is Linux, but lots of groups have run them in Windows. I'm not sure about Mac. I think I've had a few groups successfully get things to run on Macs, but for that, you have to do a bit more tweaking of your own. Okay, so the default is Linux, but definitely lots of groups have run their code on Windows, and Mac is a little bit more iffy. All right, what is the craziest language that a group successfully used? Yeah, I don't know. Probably sort of the most unusual, maybe. Well, it's not that unusual. I don't know. I mean, I would say Swift was pretty unusual, especially because groups used it back when it was completely new, and nowadays it's maybe a bit more standard. But yeah, I haven't had super bizarre languages. I don't know. Surprise me. You pick a crazy language. Just make sure it's not so crazy that it gets you into trouble getting the compiler to work. Okay, are we just outputting object files? Yes. So we're going to be we're going to be outputting assembly language files that we feed to the assembler, and so it's going to be the assembler's job to output an executable file. And so we don't have to worry about generating object files ourselves, and even the assembler, the assembler is combined with the linker, and so you don't have to worry about object files. Okay. All right. So I mentioned assembly language. So x86 assembly language. Oh no, what if you haven't ever written any x86 assembly language? So don't worry if you haven't. I will have about one lecture kind of near the end of the course when the time comes for that, sort of introducing all the basics of x86 assembly that you need to generate code. x86, I mean, it unfortunately is a language that has like 1,000 opcodes, so it's kind of crazy complicated. But out of those, there's only about 15 or 20 that you actually need to generate code. And so I'll cover those useful ones. All the other ones are useful for all sorts of processor extensions and things that we don't need for the course. Okay. Having said that, I am going to expect you to pretty much teach yourself that subset of x86 assembly that you need, but it is a small subset, and usually that's not the hard part of learning that piece of assembly language is sort of the easy part of that assignment. So there's a bunch of resources on the website here about x86 assembly. You know, I mean, there's no point looking at them now, but when you get to assignment 5, you can look at those. And there's lots of, you know, I mean, it's x86 has been around for decades, and so there's tons of information about it, you know, all over the internet. I've just collected a few resources that I think are useful. Feel free to, you know, if you find other websites that are useful, you know, feel free to share them on Piazza. All right. So I have a section here on textbooks. And so I have these 4 textbooks that I recommend for various reasons. So this year textbooks are a little bit weird. You know, so if everything was normal, I would put these books all on like 24-hour reserve in the library, and you could go and check them out and you know, have a look at them. So, you know, because of COVID, I'm not allowed to put anything on reserve. The library is not doing reserves, except for electronic reserves. And apparently some of these books are available in electronic form, but none of them are available in electronic form for libraries. So apparently the publishers have, you know, don't like to allow ebooks to be signed out from libraries. So I can't put any of them on reserve. They are in the library, and the library is doing curbside pickup. So presumably you can, you know, order one from the library, but then, you know, once one person checks it out, that's it. Like the library copy is gone. I list them here because they are useful as reference and as you know, I say they're recommended. They're not required. Everything that you should need is going to be in the lectures. But you know, if you want something to read, these are good things to read. So let me just tell you about the books, and then, you know, you can decide whether you want to get them from the library or you know, possibly buy some of them. So the first one is, whoops, not this one. So it's called Crafting a Compiler by Fisher and Citron and LeBlanc. The old version was, yeah, just Fisher and LeBlanc. So this is kind of the traditional book that's always been used for this course, and it's the sort of the main benefit of this book is that it's closest in terms of the coverage of the material that I cover in lectures. So I mean, it's definitely not the case that I go through and say, okay, now we're doing chapter 1 and now we're doing chapter 2, right? I don't really consciously follow the book, but out of the many different compiler books that are out there, you know, this is the one where the focus sort of most closely matches the focus of the lectures and the topics that you sort of most need for the project. So I mean, it's, yeah, I don't know. I wouldn't go crazy buying it unless you really want a book to match the course, but that's its main feature, that it heavily matches the course. The second book is this one by Andrew Appel, Modern Compiler Implementation in Java, and there's a C version and an ML version, but they're pretty much the same. So you know, feel free to get one of the other versions. That said, the Java one is the most up-to-date one. And so I list this book because, you know, out of all the various compiler books that are out there, this is my favorite in terms of covering interesting topics and explaining things succinctly and clearly. So, I don't know. I mean, this is my favorite book. If independent of the course, if you were going to get, if you're interested in compilers and that there's one book that you can get, this is the one that I would get. That said, only about half the book is relevant to the course. The other half is about optimization. So that would be sort of the CS444 stuff. But I mean, on the flip side, that's a good thing, right? There's more interesting topics. So in some sense, this is the book that's interesting, but perhaps not entirely helpful for the course. Now, I list 4 books here. There's zillions of other compiler books that are all, similar in various ways. I have this other one by Ken Loudon. So this book, the reason I list it here is that one of the sort of theoretically most complicated topics that we're going to look at is LR parsing. And, I've looked at lots of compiler books over the years, and that's a topic that's hard to explain. I'll try to explain it as clearly as I can in the lectures, but in terms of books explaining it clearly, this book explains it the clearest out of, at least in my opinion, and out of all the compiler books that I've seen. So if you're struggling with parsing, this is the book to look at. And otherwise, in terms of the topics covered, it's similar to the first Crafting a Compiler book, but a little bit further away from the course, but still pretty close. And then finally, there's the Dragon book, this last one. And I don't have it here. I have it in my office, but my office is locked down, so I can't show it to you. But it has a dragon on the cover, so that's why it's called the Dragon book. And this is kind of the classic compiler book. This is like the oldest book for this kind of a course. It's not really my favorite, but it is a classic, and so it should be listed in any list of compiler books. So as I said, I mean, you don't need to get them, but if you really want a book, here's some suggestions. Okay, so with that, let's look at the course project. And so normally when I teach the course, when we don't have a pandemic, I say that the project is the course. So normally what happens is 75% of your final grade would be the course project, and then for 25% we would have a final exam that would cover some of the theoretical material from the lectures. And so, even in normal times, it's really all about the project. The lectures are useful because they, tell you things that you use in implementing the project, but the evaluation, most of it is the project. This term, the project is going to be worth even more. In fact, the project is going to be worth 100% of your marks. And, I mean, the reason is that we're not allowed to have in-person exams, because of university-wide restrictions. And so, we could have an online exam, but I mean, an online exam is quite similar to an online assignment. And this is a course that has a very heavy workload of online assignments already. And so, I thought adding yet another online assignment, maybe a more theoretical one, but it's still like an assignment, I think would be overload for this course. It's not my favorite decision. I think there is value to having a final exam to, have you study the theory, to, go over your notes at the end. So, in a perfect world, that would be the breakdown that we would have. But, this year it's not a perfect world, and so this is sort of the closest approximation. Okay, so I mean, everything is going to be the course project. If you like the project, that's good. But yeah, so the course project is everything. Now let's look sort of more into the course project. And stop me if there's questions. There haven't been questions for a little while. Okay, so for the course project, well, it's split up into 5 assignments. I'll talk about those in a bit. But for the assignments, I'm going to give you Marmoset tests that are public tests. So you submit your compiler to Marmoset, it runs the test, and it tells you which test you passed. Okay, and in fact, the tests are even more public than that. So if you scroll down a bit, all the actual test inputs, so all the test programs that Marmoset uses, I am giving you on the linux.student.cs environment. So you log in there, you go to this directory, and you can find all the test cases there, and you can download them. So, not only do you know which tests you passed and failed, you know exactly what the tests are. And, I encourage you to download them and, put them in your own test suite and run them locally so that you don't have to always wait for Marmoset to run them. But, you have all the tests for, 65% of the marks. Okay, so, I mean, if you wanted to cheat, you could hard code those tests into your compiler, with the right answers, and you get 65 in the course. Don't do that. That's cheating. Don't write a compiler targeted specifically to the tests, but you do have the tests available, and you do know exactly which program your compiler is passing or failing. Okay, but I'll repeat that again. Don't write your compiler to the test. Write your compiler to the specification to be a compiler. But if it fails a test, you know exactly which aspect of your compiler is failing. Okay, so that's the public tests. There's a set of secret tests. And these are tests that are run at the very end of the course. So you can think of them as a little bit like the final exam, not really, but sort of. So these are tests where, I don't tell you what the program is, and I don't tell you which ones you've passed or failed, until the very end. Like, I'll tell you got like 18% out of these 20% of the marks or whatever. Okay, so these are tests that really are secret. And the purpose of these tests is, partly to make sure that you did write a compiler to the spec and not a compiler to the public tests. And also that, as you're writing your compiler, you should write your own tests to test it thoroughly and, test it as thoroughly as you can. And also, write a well-designed, clearly designed compiler that is unlikely to have lots of bugs, so that it will hopefully pass most of these secret tests. Those secret tests, they're not designed to be evil. They're not designed to test corner cases of your compiler. They are sort of realistic Java programs that somebody might write to compile with your compiler. Basically, the source for these programs are, many years ago. Actually, in the Aarhus version of the course, one of the assignments was, write yourself some realistic Java program that your compiler will eventually compile. Right, some program that does something interesting, like, I don't know, sorts some numbers or does some calculation or does something sort of useful. And so, they're meant to be useful, real-ish programs. And so this is just a test of, how well does your compiler do on a sort of typical population of random Java programs. Okay, so they're not designed to be evil. That said, they do reveal, if you have a messy compiler, usually it will fail, cases that you haven't explicitly tested. And on the flip side, if you have a well-tested compiler, usually it will do really well on these secret tests. Okay, they do come at the very end of the course, and they are 20%, so it is quite a lot. On the other hand, even if you fail all of these secret tests, but you pass all the tests where I'm giving you the code, right? Like I'm giving you the code of the tests. So if you pass all of those and the written reports, you've got 80%, which is a pretty good mark, even if you even if your compiler is not robust at all and fails all the secret tests. So it's kind of a trade-off there. But hopefully lots of compilers will get 100 in the course, and I'll be happy if that happens. So what I haven't mentioned are the written reports. So in the olden days, this used to count for a lot more of your mark. You wrote a compiler, and there were no marmoset tests. So you would write your own tests, and then you would write a report, and you would say, hey, look at this cool program that my compiler can correctly compile. And, you would say all the cool things about your compiler in the written report. And, that would be the basis for your mark. I don't like to kind of make up marks like that. And so, so the written reports are still 15%. There's going to be 3 written reports with assignment 1, assignment 4, and assignment 5. Basically, the one with assignment 4 covers your design of assignments 2, 3, and 4. So anyway, so there's these 3 written reports, and I just want you to tell me how you did this part of your compiler, right? What design decisions you made, why you decided to do it this way and not another way, and so on. So there's these 3 written reports. They're 5 pages each, and I just want to know what you did and why you did things the way you did them. I'm usually fairly generous in marking these, but yeah. Anyway, so you have to do a bit of writing. There's a few of you who are taking the 644 version of the course, the grad version of the course. So there, I'm asking for a literature survey as the extra thing that differentiates 644 from 444. If you're one of those people, click down here. I'm not going to go there now, but click down here for the details of that. So that's the sort of the extra project. If you would like to do something other than a literature survey, for that extra project, I'm open to discussion on that. And so, feel free to talk to me and we can negotiate a different kind of extra project. But the default is a literature survey, and there's details following that link. Okay, so questions. Stop me if there's questions. And I'm going to keep going, but don't worry about interrupting me. Go ahead and interrupt me if you have a question. Okay, so there's assignments. They have due dates. Assignment 1 is due, exactly 1 month from today. That month will go by pretty quick, so you want to get started fairly soon. But before that, assignment 0, choosing a group. So let me open that. So there's a whole bunch of stuff here that you should read, but the main thing, programming language of your choice. So you want to pick a group that can agree on an implementation language, and you want a group of 3. I guess that's the really main thing. Okay, so the project is fairly large, and you will want to have a group of 3 to be able to implement it in time. So there's like 100 people in the course, so hopefully you can find a group of 3, that has similar ideas as you in terms of working style and implementation language and all of that. This year is particularly challenging for finding a group because everything is online, nothing is in person. Normally what I would do is say, stick around after the lecture and talk to people. That doesn't work nowadays. I hope you still find ways to find a group. The 2 things that I suggest to try to help is, one, you can talk on Piazza. So, there's already a bunch of students who have posted on Piazza that they're looking for a group and some details about what kind of group they're looking for. The other thing is on Teams. So there's on Teams, there's a team that consists of everybody who's enrolled in the course. And I put a little channel there where you can, look for a group. So say, hi, I'm looking for a group. I want to do my compiler in, x86 assembly language, or I don't know, whatever your implementation language is. And the nice thing about Teams is that, if you post there, someone can right away, click and start a video meeting and talk to you, and you can sort of talk to people and get their ideas of how they want to do the project. Okay, so try Teams to find a group, try Piazza to find a group. Hopefully, despite the pandemic and despite everything, you can still find a group. But yeah, and I'm giving you a week to find a group. If you find one faster, that's great. If you don't find one, by next week, I'm going to be, contacting you to try to make sure to get you into a group. All right, and I've got a test. If we fail secret tests in earlier assignments, how likely is it that this impacts out marmoset tests in subsequent assignments? Okay, so the secret tests are, they're all, I guess I could say they're all for assignment 5. I mean, that's not totally accurate because they test functionality from your entire compiler, but all the secret tests test your entire compiler as a whole. So, they test things when it's completely done. So I won't be running the secret tests on assignment 1 and on assignment 2 and so on. They only get run at the very end of the course. So it's kind of, I guess I said it's kind of like the final exam. So in that sense, it's, a final exam tests everything that you've learned all term at the end of the term. So the secret tests everything that your compiler does at the end of the course, at the end of the compiler. That said, there are no, so in assignments 1 to 4, I test with some invalid programs, and sort of the point of the test is to make sure that your compiler detects those programs as invalid. For the secret tests, they are all valid JUICE programs. So we're not testing the ability of your compiler to detect errors. We're just testing its ability to compile code and generate working code. All right, so read all this for assignment 0. There's one other thing I want to point out at the very end here. One thing that I'm going to try that's new this term is these weekly status meetings, and sorry, I should say short weekly status meetings, so that I don't freak you out. But and from past experience, the things tend to go pretty smoothly, with the exception of groups that kind of stop paying attention to the project and the course, right? They get distracted by other courses, and all of a sudden an assignment comes due, and they're like, oh no, we better get our group back together. We better start like working on this now. And really, what even though the term is 3.5 months long, you need to be making sort of consistent progress. And the other thing that's different this term, right, is that everything is online. And I think we all need, as much interaction as we can get. So this is a way to increase interaction and to keep groups, kind of consistently making progress. So the idea is, once a week you will have a 10-minute meeting with a TA, and basically tell the TA how things are going, how the group, is the group getting into fights? Hopefully not. Or is the group working together smoothly, communicating well, and how the compiler is doing, right? Is the design coming together? And so you'll tell the TA how things are going. If things are not going well, the TAs can tell me, and I can try to help your group. And the TAs can also give you some brief advice on, how to either how to work better together as a group, how to communicate better, or possibly advice on designing your compiler. So for that, for managing these status meetings, I'm asking you to give me a time preference. And so I've, given you a number of time slots. And so when you pick your group, come up with a ranked list of these time slots, and I'll try to give you that meeting in the time slot that you prefer. Okay. All right. Oh, and I have another question about the secret tests. Okay. So the tests wouldn't test for things like adding a number in a string, using a variable that hasn't been defined, etc. So the public tests definitely do test that stuff, but you have all the public tests, and you're encouraged and more than encouraged to write additional such tests. But the secret tests that are run at the very end of the term, where you don't know, how well your compiler is going to do until the very end, those don't have things like that. Those only have valid Java programs that your compiler should accept, compile, and compile into working code. Okay. Will there be any kind of competition? Not in this course. No. So it's, the competition is you against the tests, I guess. Not against other students. Has the project always been a group project? So it has always been, ever since I took the course as an undergrad. I think it was like, maybe it was 21 years ago. Okay, well, whatever. So yeah, it's always been a group project, and the motivation is that it is a big chunk of work, and so you want 3 people to each do 1/3 of the work, or hopefully split it evenly, just because it is a lot of code to write. Write and debug and so on. So since we're talking a lot about the groups, I'm going to skip ahead here and then I'll come back. So there's this group work policy. Again, in my experience, things generally go pretty smoothly. Like most groups do pretty well, except if they have trouble getting along. So I always get the odd group that has difficulty getting along, and so the first important thing is, if you start having disagreements or resentment of something that one of your group members has done, address it early. So talk to your group members early, and try to resolve those issues. For the most part, groups can resolve those issues, among themselves. I am happy to mediate, and I mean, it's my responsibility to help your group resolve the problems. But things tend to work better if your group members can reach a compromise, can come to an agreement, possibly with my mediation. But if it's something that the group can work out, as opposed to me imposing a decision. So I try to help your group work things out. In the end, I am responsible. So I do have this sort of policy, and once again, 95% of the groups generally don't need this policy at all, and hopefully your group will be one of those that has no problems at all. But in case it comes down to it, there's this policy here at the end, and basically, number one, each group member gets the same mark by default. Number two, if the group can agree that one group member did everything and the other ones did nothing, or whatever. So if the group can agree on a different distribution of the marks, then I will follow what the group agrees to. So I want to encourage the group coming to a decision. And then number three, which actually happens very rarely. If the group can't agree and they're just, fighting and can't agree, then there's this number three where each group member can tell me their side of the story, and then it's my responsibility to make a decision, based on hearing all three sides of the story. That tends to happen maybe once every 3 years or so. Like it's very rare. I hope it won't ever happen. I think the key is to resolve problems early before they, spiral out of control. And so I really encourage you to do that. To as soon as things start getting bad, address them earlier rather than later. Okay, resources. So I mentioned, the linux.student.cs.uwaterloo.ca. So you log in there, and there's these directories. The one resource I mentioned is the test cases. So the public tests, you have all the test programs. There's also the standard library. So the thing with Java is that, even a short Java program isn't really that short, because pretty much every Java program uses something from the Java standard library. And because you're writing the compiler and I'm giving you freedom on how to compile things, the standard library you would need to compile with your compiler so that it's compatible with the code that your compiler generates. But the real Java standard library is huge, and if you couldn't compile Hello World before compiling the entire Java standard library, it would be really hard to get Hello World going. So I have written my own, tiny baby version of the Java standard library that has things like print line and the most important things, but it's small and simple and doesn't use advanced Java features so that you can easily compile it. So this is there for you as well, the standard library. And starting with assignment 2, we'll be compiling with that. Finally, I have a late policy. And basically the late policy says that each assignment has 2 deadlines. There's the real deadline, and then there's the end of the term deadline, April 14th this year. And half the assignment is due, or half the marks you get by having the assignment done before the assignment deadline, and the other half you get for what you have done by the end of the term. But of course, the end of the term is after the assignment deadline. So if you get the marks by the assignment deadline, you get all the marks. If you don't get it quite done, because the assignments build on each other, it really is, one big project. You can still get half the marks for things you finish on each assignment after that assignment's deadline, but before the end of the term. Okay, and so then there's some examples and so on. So, try really hard to get things done by each assignment deadline, but if you don't, you're still working for half the marks after each assignment deadline. Okay, and the way Marmoset works is if you ever submit more solutions, so let's say you get perfect on assignment 1, but then you want to change something and try it out, that's fine. If you submit another solution to Marmoset, even if that solution fails some test cases, that's not going to affect your mark. It's always your best submission that counts for your mark. Okay. So I wanted to get through this quickly, but it is 2:20. So I should end here. So I know this is a lot of information about how the course is going to work. On Wednesday, we can start into the technical material. I just want to give you one last chance to ask questions. So any more questions about how the course is going to work? And then, so as you're thinking about questions, let me say, so I'd encourage you after the lecture to go and try to find a group. So, go on Teams or go on Piazza and look for a group. Try to find a group as soon as you can. So any more questions about how the course is going to work? All right. Anyone? Oh, okay. So there's someone typing a question. And so for the lectures, we're going to be doing Mondays and Wednesdays from 1 to 2:20. What was the class average last term or the expected class average? I need to look that up. Generally, it's quite high. Last term, so the last time the course was offered was last winter, and it was a little bit higher than usual because we were going to have a final exam, but we had to cancel the final exam because of the COVID stuff. I don't know off the top of my head, but I believe it's sort of mid to high 80s is the typical class average. Great. Anyone else? Okay. All right. So, you'll have a chance to ask questions, in all the lectures. So I hope to see you on Wednesday at 1 o'clock. All right. So have a good couple of days, and I'll see you then.